Welcome back to the next lecture. This is S. Satish Kumar, Assistant Professor, Komunadu College of Engineering and Technology. This fourth lecture will discuss about engineering properties of soil. So while going for engineering properties of soil, the shear strength is the very important parameter in discussing about the properties of soil. The shear strength of a soil is the resistance to the shearing stress. The shear strength is in soil depends on primary on interaction between the particles. Shear strength derives by two sources. One is cohesion, another one is frictional resistance. Shear strength in the element can be tested like that. So we have an element, we are applying the force here. So due to this application of force, failure is to be occurred here. So due to this failure occur in there, we are finding out the shear strength. So this is about additional application of force over the soil. So it may be a building, a road, or any soil mass applying over the soil. So in that same condition, we are applying the horizontal force to the soil mass. So this is due to that failure will be occur. So it is also it is comes under internal friction. This is comes under cohesion. Only cohesion. This is about internal friction. And this is the formula for finding out the Morse Coulomb failure theory. S is equal to C dash plus sigma dash into tan pi dash. So this is the drawing will shows you the major stress, that is vertical force. This is the horizontal force. Based on that, we are finding out the shear strength using this graph. This is the base. C dash is the cohesion. We are draw a graph normal stress versus shear strength. It will gives you the angle of internal friction pi value. So direct shear strength can be determined by direct shear test and triaxial shear test. Uh, this is the diagram about direct shear test. This is the diagram about triaxial shear test. So direct shear test can be tested using this simple setup. So soil mass is filled with within the container up to this surrounding. The upper plate will be a porous plate. The another one is the loading yard. We are applying the vertical force through this setup. We are applying the horizontal force here through this U arc. Then we will find out the deformation. The bottom plate will be fixed during the test we started. This is the laboratory views. This is the soil preparing specimen. This can be placed inside the loading arc. After placing it to the inside the loading arc, we are applying the vertical force. Then we will apply the horizontal force also. So next method is triaxial shear test. This is very familiar one. So we are prepare a soil sample for this specimen size. Then it can be covered with some polythene layer. Then it will be inserted inside the triaxial shear test. The surrounding places will be covered with water. We are pressurizing this water. So due to this pressure, the uniform force can be applied to the soil mass. So due to this application of external pressure, it may eject some quantum of water. It can be removed from two places, and this will be considered for two cases. One is consolidation phase, one is under drained condition and undrained condition. If you are allowing the water to pull out, means it is drained condition. If we are logging this system, then we will apply the force, means it is undrained condition. So due to application of the external water pressure, the soil mass will fail in some cases. At that point, we are finding out the shear with the help of that cell pressure, we will find out the shear strength using Morse circle theory. So this is about for applying the vertical force over the soil mass. So this is the sample preparation. So this is the mold for that. We will prepare that. The final setup is here only. It can be inserted here. So pore water can be extracted through this medium, cell pressure. So up to this shear strength can be determined. So see here, this is the failure is occurred in triaxial shear test. This kind of failure will be occurred. The next one is The next one is soil permeability and seepage. Permeability is the ability of water moving, water conveying ability. Soils are assemblages of solid particles with interconnected voids where water can flow from a point to high energy to a point to low energy. The study of flow water through porous media is important for stability analysis of a earth retaining structure subjected to seepage forces. The property of soil that allows water to pass through them at some rate. So permeability of soil has decided to effect of the stability of foundation, seepage loss through embankment of reservoir, drainage of subgrades, excavation of open cuts in water bearing sand, rate of flow of water into wells, and many others. This is about Bernoulli's equation. So total head is equal to pressure head plus velocity head plus elevation head. Using Darcy's equation, we can able to find out this water movements. So this is about Darcy's law. It can be derived in the year 1856. Q is equal to KIA. Methods of determining the hydraulic conductivity. Laboratory methods that can be determined by constant head and falling head methods. Then field methods, pumping test, borehole test. Indirect method is empirical formulas. The constant head method is we are having a soil. Through this soil we are applying the water to the soil. It can be drained out some quantity. So head is to be maintained, that is called a constant head. Then falling head method is we are applying the water for different heads. So that is called falling head method. Then effects of seepage. The interaction between the soil and percolating water has an important influence on the design of foundation and the earth slopes. Then the quality of water that will be lost by percolation through a dam or its subsoil. Then this is about very important in our quicksand condition. We are applying the water to the soil. Due to this application of water, the soil particle will loosen their cohesive strength. So due to that, we are facing lot of soil liquefaction of soil problems. So thank you.